Hello, math lovers. Today's question comes from section 5.2, and it states the following. Is it possible for an odd function whose domain is all real numbers to be strictly concave up? Well, I'm just going to go ahead and answer that and say no, because that's what I hope to prove to you. Well, let's look at the question. We have three things going on. We have an odd function whose domain is all real numbers, and we want to know, can it be strictly concave up? So let's go over what these three things mean. Let's go over the easy one first. All real numbers are the domain, that is all x values covering all real numbers from negative infinity to positive infinity. So what I've done here is given two examples of concave up that have a domain of all real numbers. In this case, we have a parabola where the x goes off to infinity, same with the other side. And then I have a concave up decreasing that also has a domain of all real numbers. Now, the other thing that's mentioned is an odd function. So what is an odd function? An odd function is one where, as part of that function, any given x value opposite has a corresponding opposite y value. That sounds kind of confusing, so what I've done down here is create a table that gives you an example of what that means. If we look at any x value in this table, we have, let's say, a 2. We plug that in, we get a negative 2 equals a negative y. So our y is 1. So, and we look at the table, and sure enough, a negative 2 equals a negative 1. We could plug in any value, and this will hold true. We could use the negative 3 down here for our x value. Negative 3 equals 3. And the output is a negative y value, which a negative 0.5 equals 5. And sure enough, we have our three corresponding opposite values, 3 and 5 down here, our opposite pair. What this creates is a graph of f that is symmetric about the origin. The origin being right here. By the way, this is what this table looks like if you graph it out on this rudimentary graph here. And what that means is for every point on this side, if you go down through the origin, you will have a corresponding opposite point on this side. So up here we have 1, 2, and then directly draw a line directly through the origin, and on this side we have negative 1, negative 2. These are points that meet this requirement of an odd function. So we can see that this is both concave up and concave down. So if we have concave up on one side, we're going to have concave down on the other. And so that proves that we cannot have an odd function that is strictly concave up. But just to make sure, I'm going to show you what would happen if we applied the transformations in an odd function to a concave up shape. What we get is, in this case, if we flipped it horizontally, that is the negative x transformation, we end up with something that looks like this. And then if we flip it again vertically, we get something that looks like this. So that's what this function would look like, but as you can see, it doesn't pass the vertical line test, so it's not a function at all. Same with the parabola. If we flipped it, it would look the same horizontally, that is, this transformation. And then if we do the other y transformation, we end up with a shape that looks like this. Well, this is not a function either, because it doesn't pass the vertical line test. We would have two y values for one x value. So the answer is no, and I hope I've proven that. Thank you.